Hello students, in this session I will be explaining you about a program that is meant to find out the roots of a quadratic equation. So you all know we write program to perform specific task. So in this case we are going to deal with a program that is meant for finding out the roots of a quadratic equation. So let me just brief you about the basics of the quadratic equation. Okay, so in this case I'm Viresh Dagde from CS department. So with respect to the basics, as you all know, the quadratic equation has ax square plus bx plus c equal to 0. Okay, so in this case when I speak about this root, okay, so I'm speaking about x. Okay, a real number x will be called as solution of the root if it satisfies the equation, that is ax square plus bx plus c. If I after finding out the root, that is value of x, if I substitute it into this equation knowing the coefficient abc, the result should be 0. That is what the roots mean. Okay, so it is easy to see that the roots are exactly the x-intercepts of the quadratic function f of x. Okay, as you all know that when we draw the characteristic graph of a quadratic equation, it always leads into a parabola. Okay, so when I speak about finding out the roots, then I am trying to find out the x-intercepts of the quadratic equation. Fine, so this is what I am trying to say, that is the intersection between the graph of the quadratic function with the x-axis. Okay, so at the left hand, so these are the x-intercepts, these are the roots. Okay, when a is less than 0 or a is positive, okay, these are the roots of the quadratic equation. Okay, let me just begin with the algorithm. Okay, here we have a 8-step algorithm that is meant to find out the root of the quadratic equation. Fine, so initially I will be reading the coefficients abc as the inputs. Okay, and the first and foremost thing, I would like to check the product of the coefficients. Okay, so if any one of the input or if two inputs are 0, then product will be 0. That would lead to a conclusion saying that we cannot find out the roots of the quadratic equation. Okay, or if any one of the input is 0, it may lead into a linear equation rather than quadratic equation. Okay, so in that case I do what is, I skip all the remaining steps and directly go to step 8. Okay, that is end of the algorithm. Fine, else I'll do what is, I'll compute the discriminant. Okay, discriminant equal to b square minus 4ac. Okay, as you all know that to find out the roots of a quadratic equation, we have a basic formula, that is minus b plus or minus square root of b square minus 4ac divided by 2a. Okay, so for that discriminant, that is b square minus 4ac, I would like to make use of a variable disc in which I will be storing b square minus 4ac. Okay, then using the value discriminant, I would come up with some conclusions. Okay, or some probabilities. Okay, so if the discriminant, so in after third step I come to fourth step and check out if discriminant equal to 0, then I directly say that the roots are equal. Obvious it is. So equal roots are computed as root 1 equal to root 2 equal to minus b divided by 2a. Sensible. Fine, then in the fifth step, if this is not the case, if discriminant is not 0, bind positive or negative. Okay, so if it is positive, okay, that is if discriminant is positive, then the roots are real. Okay, so real roots are computed as root 1 equal to minus b plus square root of discriminant. This discriminant is minus b square minus 4ac, so that value will be substituted directly if I use discriminant. Fine, divided by 2a. Then root 2 is minus b minus square root of discriminant divided by 2a. Fine with this? Okay, so if this is also not the case, okay, in step 4 if discriminant equal to 0, in step 5 if discriminant is greater than 0, okay, if both the conditions are false, then obviously discriminant is less than 0, negative. Okay, in that case the roots are imaginary, or we can say that complex numbers. Okay, so where real part is computed as minus b divided by 2a, and imaginary part is square root of f abs, okay, absolute value of discriminant divided by 2a. Okay, hence root 1 is real part plus I times of imaginary part, root 2 is real part minus I times of imaginary part. So real part and imaginary part are computed using these equations. Minus b divided by 2a refers to real part, square root of discriminant divided by 2a is the imaginary part. That ends the algorithm. Okay, the same I can represent pictorially, okay, or graphically, okay, using a flowchart. I start and read the values of coefficients. Then, as I said, first and foremost thing, I have computed the product. If the product of a into b into c is 0, then I say the roots cannot be formed, and it directly goes to what? The last step, or it goes to stop. Okay, so if this is not the case, if this is true, then if this condition, that is a into b into c, is true, then it stops saying roots cannot be formed. Else it goes to the false part and say it computes the discriminant. Okay, as you saw in the algorithm. Okay, if this is not true, okay, then it computes the discriminant. Okay, the same lines, it is computing the discriminant. Discriminant is b square minus 4ac. So after that I go on checking the values of discriminant for 0, whether it is 0 or whether it is greater than 0 or whether it is lesser than 0. If it is 0, roots are equal. If it is greater than 0, roots are real. If it is less than 0, the roots are imaginary, or the roots are complex. Over here it is been misprinted, roots are complex numbers. Okay, so with respect to that, we have the formulas over here. Roots, if roots are equal, root 1 equal to root 2 equal to minus b divided by 2a. After it computes, it comes directly out and prints the roots. Okay, so remember one thing, at any one point of time the discriminant might be 0 or greater than 0 or less than 0. It cannot be all the three at a time. Okay, either of the three condition, one condition would be true, and with respect to that we would be computing the equal roots or real roots or distinct roots. Okay, that is complex roots. Okay, so with respect to each individual roots, we have the formulas. Okay, and after computing the roots, it comes out and prints the roots. Okay, and directly goes to the top. Okay, that's it about the flowchart. Okay, now let me show you the program. Okay, so this is the program. Okay, as you can see, I have just made use of some header files. Okay, and to compute the product, to have the coefficients, I have declared three variables ABC. Okay, and to store the discriminant value, I have declared the variable discriminant, real part, imaginary part, and to hold the roots x1 and x2. Okay, so first I do what is, as per the algorithm, read the coefficients. Okay, using scanf, I have read the three coefficients. Okay, first thing I compute the product. Okay, if the product is 0, okay, then directly I say roots cannot be found, and I say return. Okay, when I say return, the further steps are been skipped and it directly comes to this end of the program over here. Fine. So in this case, if I enter some non-zero coefficients, it would come to this statement. It will never enter this statement. These statements. Okay. So now if I assume that you have entered some non-zero coefficients, so the control comes to this part. Okay, so I compute the discriminant as b square minus 4ac. Okay, that is b into b minus 4ac. Okay, after I compute this, I would be getting some discriminant value. So it would be either 0 or positive or negative. Okay, so based on positiveness, negativeness, or 0, the roots are being computed. Okay, so in this case I'll just take an example. If discriminant is 0, I say roots are real and equal. So x1 and x2 are been computed as minus b divided by 2a. Okay, so x1 is printed as what? X1, x2 is printed as x2. Okay, because x1 and x2 both are minus b divided by 2a. as I said, roots are real and equal. The same holds to the remaining, if the roots are real and distinct, or if the roots are complex numbers, that is imaginary. Fine. So I hope you have understood the program. Okay, let me just show you the output of this code. Okay, the program is roots quadratic.c. So go to application, system tools, terminal. Okay, so compile it. This is how I compile. Oops, over here I have missed link math, because I am making use of some mathematical functions like square root, okay, and FABS. Okay, I need to make use of link math to link the mathematical library functions. Okay, LM. Fine. So now there are no errors. Okay, how to execute? Okay, enter the coefficients. I'll enter the coefficients as 1, 2 and 3. It says roots are complex. So the complex roots with real part and imaginary part are x. Okay, and let me enter some other inputs. 1, 2, 1. I'll get roots as real and equal. So real and equal roots are -1 and -1. Okay, let me enter some more inputs. 1, 3, 1. Okay, now it says roots are real and distinct. Okay, so by this I hope you have understood the roots of quadratic equation program thoroughly. Okay, thank you.